Welcome to ChemVid. Today we're talking about limiting and excess reactants. So you guys already know this. When you look at anything that you're trying to make, you always have something that limits how much you can make. Alright, so a limiting reactant is the one that limits. An excess reactant is the one you have enough of or plenty of whenever you're making something. Okay? So our equation that we use is initial, what you have initially, minus what you used is equal to your excess, or whatever is left over. So let's think of it as cars. If I have 8 car bodies and 48 tires, I can make 8 cars. But I have 16 tires left over. Well, the 16 tires can't be used because I ran out of car bodies. Alright? So my car bodies are my limiting reactant. My tires are my excess reactant because I have plenty of them. And my product are full cars. Okay? So let's talk about this in something a little more tasty. S'mores. S'mores are known by everyone and they are delicious. So we are going to use those in order to talk about limiting reactants. Okay, so the first thing I'm going to do is write a balanced chemical equation for a s'more. So I like 2 graham crackers. GR is my graham cracker, plus 4 pieces of chocolate, plus 1 marshmallow creates 1 s'more. Now, if you're fancy, you can add a little delta above that. That means that the reaction has to be done with heat. Okay? So a little triangle above the arrow means the reaction is done with heat. Then, I balance the equation, saying that I need 2 graham crackers for every 4 chocolates for every 1 marshmallow, and that makes 1 complete s'more. So this is a synthesis reaction, all right? So how many s'mores can you make with the materials that I have been given? Well, let's see. Let's say you have been given 25 graham crackers, you've been given 40 pieces of chocolate, and you have been given 20 marshmallows. How many graham crackers could you make if you were given these materials? And identify the limiting and the excess reactant. Go ahead and try it. Pause and try it. So what I did, in order to find my limiting reactant, or what I could make, I converted all of my individual pieces into how many s'mores I could make with those pieces. So if I have 25 graham crackers, I can make 12.5 s'mores, because I need 2 graham crackers per s'more. 40 chocolates, I can make 10 s'mores, and 20 marshmallows, I can make 20 s'mores. So my limiting factor, the one that limits me, is the one that makes the least amount of s'mores. Because after 10 s'mores, I can't make any more. I have run out of chocolate, and so therefore chocolate is my limiting factor. However, my excess is the one I have plenty of. And if you look, I have enough graham crackers to make 12.5, and I have enough marshmallows to make 20, which means that these guys, graham crackers and marshmallows, are my excess, because I have those left over. If I had more chocolate, I could make more s'mores because there's more graham crackers and more marshmallows left over. Okay? So this is pretty simple and very straightforward. We do this all the time when we're cooking. However, what if I gave you the amounts of graham crackers, marshmallows, and chocolate in grams instead of pieces, like is represented in my balanced chemical equation? So, if I have 283 grams of marshmallows, 96 grams of chocolate, and 453 grams of graham crackers, how many s'mores could I make? And if you look right here, here are the conversions for grams to pieces. See if you can do number 3. Go ahead and give it a shot. It may seem easy, but just give it a shot. So I've set them up so that I start off with my grams, because that's what I know. Then what I have to do is I have to get this guy to something that I can relate to. In my balanced chemical equation, it talks about pieces, or like 1 single marshmallow. So I use the conversion grams to marshmallows so that I know how many marshmallows I have when they give me grams. Then I use my balanced chemical equation to go from marshmallows to s'mores. So hopefully you're seeing a pattern here. It's just like chemistry. I had to get grams into moles because that's what related my recipe together. And then once I was in my recipe, I could go back and forth between the different substances. Okay? So I did the same thing with the chocolates. 96 grams, that's how much chocolate I have. And one piece of chocolate weighs 2.97 grams. And then I need 4 chocolates for 1 s'more. And for graham crackers, I started off with what I had, made it into pieces or actual graham crackers, like the piece of graham cracker. And then I needed 2 for every s'more. Alright, so I can set this up just like I do with stoichiometry. So now once I do that conversion, it makes it really easy to see how many s'mores and marshmallows and chocolates I need. And with the amount of marshmallows I have, I can make 39.6 s'mores. So since we're dealing in whole s'mores, and I can't have part of a s'more, it would be 39. Here I have 8 s'mores, if I use the chocolate. And here I have 33.6, so 33 s'mores, if I use the graham cracker. So again, chocolate is my limiting factor because it makes the least amount of s'mores. I run out of it first. And graham crackers and marshmallows are my excess because I have plenty of them or I have lots left over type thing. Okay? So far we have answered how many can I make? I can make 8 because of my limiting factor. Chocolate is my limiting reactant. Graham crackers and marshmallows are my excess reactants. So how much excess marshmallow is left over? That's the question I'm working on right now. So I need to find out how much excess marshmallow is remaining in grams. So let's think about this. How would I find out how many marshmallows are left over after making a s'more? Well, if I make 8 s'mores, I have just used 8 marshmallows, correct? Because every s'more needs at least 1 marshmallow. So after making 8 s'mores, like I can with my chocolate, I have just used up 8 marshmallows. And if that's the case, then I would take the number of marshmallows I started off with, which is 238 grams of marshmallows. I would subtract the 8 marshmallows that I used up in my process of making s'mores, and that would give me how many marshmallows remained. Okay, so let's figure this out using stoichiometry. Okay, so there are 2 ways to find an excess amount. I can either start with the amount of product that I know that I made using my limiting reactant, or I can start with the amount of marshmallows I had and see how much I would use up. Okay, so the first way we're going to do it is where we find out how much product I made, and going back from product, see how much marshmallows I used. So this way, I start off with 8 s'mores, because if you recall, I had 8 s'mores from my chocolate, which was my limiting reactant. So I start off with 8 s'mores, s'mores to marshmallows, marshmallows to grams of marshmallows, and I find out that I needed 23.76 grams of marshmallows to use up all of my chocolate. So this is the amount that I used in my chemical reaction. Well, if I want to know how much is left over, I'm going to start off with what I started off with. So in this case, I started off with 283 grams of marshmallow. That's what it said in my problem. That's what I started off with. If I subtracted what I used from my reaction, what it took me to make those 8 s'mores, then I get how much is left. So what I did was I took my initial, what I had in the beginning, I subtracted the amount that I actually used in my chemical reaction, and I get the excess is left over. So when they asked how many grams of marshmallow is left over, 259.24 grams of marshmallow is still there. That's how much marshmallow I have. Okay? So that's the first way. Again, the first way is by taking how much product you know you made from your limiting reactant and going to the excess reactant and then doing initial minus used equals excess. So on your note somewhere, I want you to write that down. I want you to write that process down. So the second way you can find your excess is by starting off with your limiting reactant, because we know that all of this limiting reactant has to be used up in my chemical reaction because it's the limiting one and therefore it's the one that runs out. So I can go from my limiting reactant, go to my molar relationship, or in this case my piece by piece relationship. I know that for every 4 chocolates I use, I need 1 marshmallow, so I use that ratio to get how much marshmallow was used. Okay, and now in this one I'm left with 8.08 marshmallows used, and so if I want it, I can simply subtract what the initial minus the used, and I can get my excess. It's the same way, but here I need to be careful, because in this one I only went to marshmallows and the initial marshmallows are in grams. So I need to do one more conversion first before I can actually do the initial minus used. I have to get 8.08 marshmallows into grams. So in this case, if I go all the way to grams, I have 48.48 grams of marshmallow used in order to react perfectly with my chocolate, which is my limiting factor. So then I take my initial minus the stuff that I used in my reaction, and that gives me an excess of 234.52 grams. Now if you notice, both ways produce different values for the excess. And you may think, well, how is that possible? But if you remember, when we did our s'mores, I rounded my s'mores to 8 s'mores total, and then I did all my calculations. But with this one, I had a perfect 96 grams of chocolate, and so it used all of the chocolate. So in this example, it's a little off because my s'mores are 1 total s'more, and so 1 I rounded and 1 I didn't. But when you're doing this with chemicals, and you're doing it with grams and everything like that, they will fit much better. Okay, you might get a little bit off due to some rounding error, but both will give you the correct answer. Okay? Alright, so somewhere on your notes, I want you to make sure you have the 2 ways to find excess written down. Because usually what gets people stumped are just the little things. They can do the stoichiometry just fine, but it's just the little things that get them mixed up. So please write these down somewhere. The first one, start with the amount of product that your limiting reactant can make, and then convert it to your excess reactant, and then initial minus used. And the second one is, start with the amount of limiting reactant you have, convert to excess reactant, and then you can do initial minus used equals excess. Both of these will work, okay? And if you notice, both of these are dependent upon the limiting reactant. That's because the limiting reactant controls how much product I can make, okay? So whenever you're trying to find excess reactant, you always have to know your limiting, because that's what's going to stop you from using any more of your reactant. So if you notice on your notes, I already have the first way to find an excess reactant outlined right here, 1 through 3. But I don't have the second one. So make sure you have the second one down somewhere, like down here. Alright? For homework, I'd like you to try number 1 using the principles we discussed. There are hints on the left and we'll see you in class.